Now, in the world of modern software, applications aren't these giant standalone fortresses anymore. Not at all. They're more like distributed teams of elite specialists, all working together on a common goal. But how do they talk to each other? How does an action in one corner of the system trigger a perfectly coordinated response somewhere else? Well, they use an invisible nervous system, and that system is called Inter-Process Communication, or IPC. That's exactly what we're going to unpack today.
So, here's our game plan for this explainer. We're going to start by looking at this new architectural reality, then explore the two main paths for communication. After that, we'll introduce the real hero of our story, the message broker, and then get into the universal language these systems use to speak. And finally, we'll look at the big strategic choice an architect has to make, and see how it all comes together to build something truly powerful.
I really want you to let this metaphor sink in for a second. Think about it. Without a nervous system, your body is just a collection of disconnected parts, right? It can't do anything. Well, the exact same thing is true for modern software. IPC is what turns all these isolated services into a single intelligent entity. It's the difference between the system that can flawlessly process your online order and one that just falls apart.
Okay, so to really get why this nervous system is so absolutely critical, we have to start here, in Section 1, a new architectural reality. This is all about a massive shift in how we build software, moving away from one giant application to a whole team of focused, elite specialists.
This slide really just nails the two worlds we're talking about. On the left, you've got the monolith giant. It's powerful, sure, but it has this one critical weakness. If one little part of it gets sick or fails, the whole giant can grind to a halt. But on the right, you have the modern approach, a team of elite specialists, what we call microservices. One service handles user accounts, another handles payments, a third handles inventory. They are masters of their specific domains. But, and this is the key, for them to accomplish anything meaningful, they have to be in constant communication. And this isn't just some technical detail, it is the absolute foundation of the business itself.
So, if all these specialists need to be talking all the time, that brings us right to our second section, the two paths for communication. We've got our team assembled, but how are they actually going to talk to each other? This decision is one of the most critical an architect can make.
And here they are, those two choices, perfectly framed by these two analogies. On the left, you've got synchronous communication, which is basically a phone call. It's direct, it's immediate, but both you and the person you're calling have to be on the line at the exact same time. If their line is busy, or worse, their phone is off, the call fails. Done. On the right, you have asynchronous communication, good old-fashioned postal mail. You send a letter, and the post office holds on to it until the recipient is ready to pick it up. The crucial takeaway here is this. The phone call is fast but brittle, creating what we call a tightly coupled system. The postal mail is slower but incredibly resilient, creating a loosely coupled system. And that distinction, well, it changes everything.
So let's dig a little deeper into that phone call model, which is usually built on something called HTTP. Think of these methods as the vocabulary of that direct conversation. They're the verbs that say exactly what you want to do. A GET request is like asking to read some data. You're just taking a book off a library shelf. A POST is for creating something brand new. You're donating a new book to the library. A PUT is for updating something, replacing a worn-out copy. And delete? Well, that one's pretty obvious. You're getting rid of the book. Each of these is a direct request that expects an immediate response.
But that directness, that need for an immediate response, is a huge double-edged sword. It creates fragility. And this brings us to Section 3, the broker's superpowers, where we get to meet the real hero of our story, the solution to all this fragility and the undisputed champion of resilience.
And there it is, the message broker. This is the post office from our earlier analogy. It's a special piece of software that sits right in the middle of our services, acting as an intermediary. Its entire job is to accept messages from a sender and just hold on to them safely until the receiver is ready to process them. This one simple idea is what unlocks incredible levels of resilience and flexibility in our software.
Okay, so the broker's first superpower is something called temporal decoupling. That's a fancy way of saying we're separating our services in time. With the broker, the sender and the receiver no longer have to be awake at the same moment. This means their life cycles are totally independent. A service can go down for maintenance, it can restart, it can crash, and the sending service doesn't even notice. The broker just holds the mail. This right here is the foundation of a truly fault-tolerant system.
And this analogy just illustrates it perfectly. We all use YouTube, right? A creator uploads a video, they are the publisher. Do they need to know if you're online right now? Of course not. They just send the video to YouTube, which acts as a massive message broker. YouTube processes it,
prepares notifications, and then millions of subscribers, the consumers, can watch that video whenever it's convenient for them, hours, days, even weeks later. This system is incredibly resilient precisely because it doesn't depend on everyone being available at the same time. That's temporal decoupling in the real world.
The broker's second superpower is backpressure. This is a system's survival instinct. Just imagine a massive flood of traffic, like thousands of orders pouring in every single second during a Black Friday sale. A single service trying to handle all of those direct phone calls would just crash. It would fall over. But this is where the broker becomes a shock absorber. It steps in, creates a buffer, and soaks up that flood of messages into a queue. This protects the service downstream, allowing it to work through the messages at its own sustainable pace.
And the warehouse analogy makes this crystal clear. The message broker is the loading dock. The messages are the delivery trucks. During a holiday rush, dozens of trucks might show up all at once. The loading dock doesn't just let them all flood the warehouse. No way. It lines them up, safely, allowing the warehouse staff, that's our receiver service, to unload them one by one, without getting completely overwhelmed. This prevents lost shipments, or in our case, lost data, and it keeps the whole operation running smoothly, even under extreme stress. That is the strategic power of backpressure.
So we've covered how our services talk to each other. Now let's move on to Section 4 and discuss what they're actually saying. Because for all this amazing communication to work, they need to speak a shared universal language.
And today, that language is overwhelmingly JSON. Now, what you're seeing here is a perfect example of a complex business order represented in JSON. I know, it might look a little intimidating at first glance, but just take a second to look at the structure. You can see things like customer ID, and then you see a list of items inside those square brackets. Let's actually break down how this works.
Okay, so at its very heart, JSON is just made of keys and values. You can see that in step 1. The key is the label, the value is the data. Simple enough, but the real magic comes in step 2, with those square brackets. That's an array, and it lets one single order contain a whole list of many different items. And then in step 3, the curly braces group data together into what we call objects. So if you think back to that full order on the last slide, each book in that order was its own neat little package of information.
So what's the big strategic payoff for structuring our data this way? Well, this quote just says it all. Because we can package the entire business context, the customer, the order ID, and all of its items, into a single message, we drastically reduce the number of back-and-forth network calls. Can you imagine if the ordering service had to make a separate phone call for every single book in the order? The system would be incredibly slow and chatty. JSON lets us be efficient, and that efficiency leads directly to better performance and faster development.
Okay. This brings us to a really critical moment in Section 5, an architect's strategic choice. We've seen the two communication paths, we've met our hero, the broker, and we understand the language they speak. Now, it is time for the final verdict.
This strategic battle card lays out the trade-offs perfectly. With invocation-based communication, our phone call, the path is direct, but if the receiver fails, the communication fails, and the data is very likely lost. This creates tight coupling. The end result is low resilience, the system is fragile. But with a message-based approach, using a broker, we get loose coupling. This is the holy grail. Services have independent life cycles, and the result is high resilience. The system can tolerate failures and recover gracefully. For any system that's truly critical, well, the choice is pretty clear.
So let's bring this all together in our final section, building the unified organism. Here are the most important takeaways that you need to remember from all of this.
Here are the 5 things you absolutely need to walk away with. First, inter-process communication isn't optional. It's mandatory for microservices to collaborate at all. Second, asynchronous communication equals resilience, all thanks to temporal decoupling. Third, loose coupling is always the strategic goal. It's what lets your services scale and evolve independently. Fourth, that doesn't mean synchronous calls are bad. HTTP is perfect for direct intent when you absolutely need an immediate answer to continue. And finally, JSON is the standard. It's the universal language for describing complex business realities.
And so, I'll leave you with this final thought to chew on. Take a hard look at the systems you build or work with. Are they just a collection of brilliant but ultimately isolated specialists? Or have you built that invisible nervous system that allows them to act as a single, unified, and truly resilient organism? Because the difference between those two things is everything. Thanks so much for joining me.